It's interesting that some people find science so easy and others find it kind of dull and difficult. Especially kids, some of them are just eat it up. And I don't know why it is. It's the same perhaps for all subjects. For instance, lots of people love music and I never could carry a tune. And I lose a great deal of pleasure out of that. And I think people lose a lot of pleasure who find science dull. In the case of science, I think that one of the things that make it very difficult is it takes a lot of imagination. It's very hard to imagine all the crazy things that things really are like. Nothing's really as it seems. We're used to get, hot and cold, and all that hot and cold is the speeds that the atoms are jiggling. If they jiggle more, it corresponds to hotter, and colder is jiggling less. So if you have a bunch of atoms, a cup of coffee or something sitting on a table, and the atoms are jiggling a great deal in the coffee, and they bounce against the cup, and the cup then gets shaking, and the atoms in the cup shake, and they bounce against the saucer, and the heat heats the cup and heats everything else. And hot thing spreads its heat into other things by mere contact, because the atoms that are jiggling a lot in the hot thing shake the ones that are jiggling only a little bit in the cold thing, so that the hot heat, we say, goes into the cold thing. It spreads. But what's spreading is just jiggling and irregular motions, which is easy to kind of understand. It brings up another thing that's kind of curious. That I say that things jiggle, and if you're used to balls bouncing, they slow up and stop after a while. But we have to imagine with the atoms a perfect elasticity. They never lose any energy. Every time they bounce, they keep on bouncing all the time. They don't lose anything. They're perpetually moving. And that the things that happen when we say something loses energy, if a ball comes down and bounces, it shakes irregularly some of the atoms in the floor. And then when it comes up again, it leaves some of those atoms moving, the jiggling. So as it bounces, it's passing its extra energies, its extra motions, to little patches on the floor each time it bounces, and loses a little each time, until it settles down, we say, as if all the motion has stopped. But what's left is the floor is shaking more than it was before, and the atoms in the ball are shaking more than they were before. That the organized motion of all these atoms moving the same way, falling down, and the quiet floor is now transformed into a ball sitting on the ground. But all that motion is still there in a form, or the energy of motion, in the form of the jiggling of the floor, which is a little bit warmer. Unbelievable. But anybody who's hammered a great deal on something knows that it's true, that if you pound something and hit it a lot, you can feel the temperature difference. It heats up. It heats up simply because you're jiggling it. This picture of atoms is a beautiful one. That you can keep looking at all kinds of things this way. You see a little drop of water, a tiny drop. And the atoms attract each other. They like to be next to each other. They want as many partners as they can get. Now, the guys that are at the surface have only partners on one side here, in the air on the other side, so they're trying to get in. And you can imagine this team of people, these teeming people, all moving very fast, all trying to have as many partners as possible. And the guys at the edge are very unhappy and nervous, and they keep pounding in, trying to get in, and that makes it a tight ball instead of a flat. And that's what, surface tension, the way when you realize, when you see how sometimes a water drop sits like this on a table, then you start to imagine why it sits like that, because everybody's trying to get into the water. And at the same time, while all this is happening, there are these atoms that are leaving the surface, and the water drop is slowly disappearing. I find myself trying to imagine all kinds of things all the time, and I get a kick out of it, just like a runner gets a kick out of sweating. I get a kick out of thinking about these things. I can't stop. I mean, I could talk forever. If you cooled off the water so the jiggling is less and less, and it jiggles slower and slower, then the atoms get stuck in place. They like to be with their friend. There's a force of attraction, and they get packed together. They're not rolling over each other. They're in a nice pattern, like oranges in a crate, in a nice organized pattern, all just jiggling in place, but not having enough motion to get loose of their own place and to break the structure down. And that's what I'm describing as a solid. It's ice. It has a structure. If you held the atoms at one end in a certain position, all the rest are lined up in a position sticking out, and it's solid at the end. Whereas if you heat that harder, then they begin to get loose and roll all over each other, and that's the liquid. And if you heat that still harder and they bounce harder, then they simply bounce apart from each other, and they're just individual, I say atoms, it's really little groups of atoms, molecules, which come flying and hit. And although they have a tendency to stick, they're moving too fast. Their hands don't grab, so to speak, as they pass, and they fly apart again. And this is the gas we call steam. You can get all kinds of understanding. When I was a kid with this air, which I was always interested in, I've noticed that when I pumped up my tires in a bicycle, you can learn a lot by having a bicycle. They'd pump up the tires that the pump would get hot. And that also understandable. See, as the pump handle comes down and the atoms are coming up against it and bouncing off, and it's moving in, the ones that are coming off have a bigger speed than the ones that are coming in, so that as it comes down, and each time they collide, it speeds them up. And so they're hotter. When you compress the gas, it heats. And when you pull the piston back out, then atoms which are coming fast at the piston feel a receding or sort of a give. It gives, and it comes out with less energy. It's like going up against something which is soft and yielding. It goes boom, boom, and it loses. So as you pull the piston out and the atoms are hit, they lose their speed and they cool off. And gases cool when they expand. And the fun of it is that all these things which you see or notice in the world about it, the pump heats the gas, or the gas cools when it expands, or the steam evaporates until you cover the cover, and all these things you can understand from these simple pictures. And that's kind of a lot of fun to think about. I don't want to take this stuff seriously. I think we should just have fun imagining it, not worry about. There's no teacher going to ask you questions at the end. Otherwise, it's a horrible subject.